Okay, in this example, we're going to be graphing a rational function. But before we do this, let me give you guys a small review of vertical asymptotes and horizontal asymptotes. So when you're asked to find a vertical asymptote, the very first step is you guys have to factor the numerator and the denominator. And the idea is you should simplify the fraction before you find the vertical asymptotes. So in this example right here, f of x is x times x plus 1 divided by x times x minus 1. You can see that we can cancel out the x, and so you look for the vertical asymptotes in this simplified fraction. And remember from the homework, the vertical asymptotes, you find them by setting the denominator equal to 0. So you will set x minus 1 equal to 0 and then solve for x. So here the vertical asymptote for this example will be x equals 1. Okay, now for the horizontal asymptotes we have three cases, and here I'll be looking at the degree. The degree is the x with the highest power in the rational function. So first case is the degree is of the numerator, the top, is less than the degree of the denominator. Then the horizontal asymptote will be y equals 0. Okay, that's case 1. Case 2 is when the degrees are the same, so they share the same power, the same highest power. When that happens, then the horizontal asymptote will be a fraction, and this fraction is obtained by looking at the leading coefficients. So this a is a number multiplying x with the highest power in the top, and this b is a number multiplying x with the highest power in the denominator. Okay, and then if we have if the numerator has a bigger power than the bottom, the denominator, then there's no horizontal asymptote. Okay, so let's go back and let's do this rational function. Let's graph it. So to find the vertical asymptotes, we set the denominator equal to 0, and so we have phi x plus 6 equals 0. When we solve for x, we get negative 6 over 5, which is roughly about negative 1. Okay. So the vertical asymptote gets an equation x equals negative 1.2. The horizontal asymptote, this is where we look at the highest power of the numerator, the degree. So here the highest power, the degree is 1. The degree of the denominator, you can see there's only one x, and so here that power is 1. So they share the same degree. And so when that happens, the horizontal asymptote is a fraction. And what you do is you look at the number multiplying x with the highest power, in this case negative 6. Careful with the negative, so it has a negative. And then on the bottom, the number is 5. Okay, so the horizontal asymptote is negative 1.2. To find the x-intercepts, so let's find the x-intercepts and the y-intercepts. To find the x-intercepts for rational functions, you set the numerator equal to 0. The y-intercepts are, you find them in the old-fashioned way. You plug in 0 for x and you find this number. Okay, so let's go find this x-intercepts, if any. So we set the numerator equal to 0, and then we solve for x. So moving or adding 6 to both sides, we get 2 equals 6x divided by 6, and we get x equals, and when we simplify this, okay, 1 over 3. Okay, so the x-intercept is 1 over 3 comma 0. The y-intercept we replace x with 0, and we find this, simplify this, find this number, which is 2 over 6, and so the y-intercept will be 1 over 3. So it will be, so the y-intercept is 0, 1 over 3. Okay, so far this is what we have. Okay, we have these asymptotes, they are at negative 1.2. That's the vertical asymptote. So we go and label, so this is negative 1, negative 2, and the vertical asymptote passes through negative 1.2. So draw a line. There's a horizontal asymptote at negative 1.2, so we go to negative 1, negative 2, and at negative 1.2, so this line here, so y equals negative 1.2, so we have these asymptotes. Now we can also plot x-intercepts. Let me do that in blue. So the first, the x-intercept is 1 over 3, so that's 1/3 here, 1 over 3. The y-intercept is also 1 over 3, so we divide into 3 pieces, and one piece will be the y-intercept. You notice that all the rational functions, when they approach these vertical lines, they go up, 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 never crossing the line. And then when there's this horizontal asymptote, they get closer and closer to the asymptote. So we're almost there. We almost have this this graph. It's just that we are missing the left hand side, the left part of the graph that is to the left of the vertical asymptote. So what do you guys do? What you do is you plug in an extra x value. So in this case, you could plug in negative 2, and so to finish, let me plug in. You can actually use a calculator for this. The idea is to finish, you can plug in another value which is to the left of this asymptote. You guys can check that if you plug in negative 2 for x, the y value is negative 3.5, and using this extra point, negative 2 is negative 3.5, so negative 3, which is about here. Okay, then what happens is, basically you guys just try to remember what happens at the vertical asymptotes. So here the horizontal, so that it is approaching this horizontal asymptote, and for this other guy it will be basically going down like this. Okay, so that will be the graph. Let me use the graphing calculator to quickly show you how you guys can do this. So we go to y equals, for a fraction, make sure you guys put the numerator in parentheses, so 2 minus 6 x in parentheses, that's the numerator, divided by, also the denominator has to go in parentheses, 5x plus x plus parentheses. Then when you click on graph, you should see a graph that resembles the one we just graphed. Okay, if it's a multiple choice, I mean, you can just graph it using the calculator and then look at the choice that matches the graph.